Okay, pause and copy, and let's get started. So same question, but now we'll try to find a line that intersects perfectly with the plane to solve our question. So which line is that? Well, it's the line that goes through P and Q. So we'll use this line in red here. Da, da, da. Da, da, da. So this line here. Which we will call L. So the line forms a right angle with the plane, and that will be a key fact that we'll use because we need an equation for the line. So the usual thing, P is equal to P0 plus T times direction vector. Now P0, or P naught if you will, is any point on the line. So I don't have Q, but I do have P, so I'll use that guy. So I'll use this guy for my P naught. Because P naught can be any point on the line, of course, put into vector form. So T, now I need T times direction vector. Here's the key point. Direction vector. I need something that's parallel to the line. But if I think about the normal vector for the plane, if this is the origin down here, here's my normal vector. Maybe it goes down, but whatever, it doesn't matter. The point is that this normal vector is parallel to this line. So I can use that normal vector as a direction vector. So I can extract that again from my normal or scalar equation here. It's 1 to -1, the coefficients of x, y, and z. Okay, so now I will take this line and try to intersect it with this plane here to find Q. So what does that mean? Well, I'm going to try to find a point that is on the plane, but also on this line. So I can rewrite this line. I can rewrite it as in what's called parametric equations. X, y, z is equal to 3, 1, 7 plus t 1, 2, -1. So if I write out the parametric equations, I get, so this is still my line L here. X is 3 plus t. Y is equal to 1 plus 2t. Z is equal to 7 minus t. So if I'm looking for a point that's on this line and on this plane, well, what I can do to find that is just take these, I can take x, y, and z and plug it in here to figure out what must be true for this point I'm looking for. So we'll say into the plane. So why don't I just copy down the plane again? So again, I'm taking x, y, z here, plugging it in there. So I get 3 plus t plus 2, 1 plus 2t minus z, 7 minus t. Careful with the brackets. So what do I get? If I look at my t's, I got 1 plus 4 is 5 plus 1 is 6t. So I got 6t, and then I got 3 plus 2. 3 plus 2 is 5. Minus 7 is minus 2. So I get that. So 6t is equal to 18, t is equal to 3. So this is not a point. This is just a parameter value, 3. So I need to take this parameter value 3 and plug it back into my line. So I'll say into the line. So x is equal to 3 plus 3. Y is equal to 1 plus 2 times 3. Z is equal to 7 minus 3. So the point Q is equal to 6, 7, 4. Just like I found last time. And the distance is again PQ. And this you could find same, we'll say same method as before. I'm not going to change that part of the calculation. Okay, so intersections. To find the intersection point, to find the point closest. So I have given you 2 methods to solve this type of problem, and you can use whichever you want. For this one here, which I will change this, this is an exercise, but it is an example in the book, so you can check your answer and check there's a solution in the book.